For our second exercise, we will use as a starting point not the empty example template as we did before, but exercise 1, hello world. Because I want to reuse the text, I want to reuse the font, so instead of duplicating, having to do that again, duplicating work, I'm going to reuse those steps that we already did. But I want to keep the hello world as it is. So what I'm going to do is, with a right click, duplicate that exercise. And I'm going to rename the folder to exercise 2. And this exercise will be about graphics matrices. So I'm going to call it graphics matrix. So by renaming the folder is merely cosmetic. It has no impact in the final application that we will develop. It's just for ourselves. It has no importance for Xcode. It has no importance for openFrameworks. So if we double click, if we enter the folder, we see that the Xcode project is still called empty example. So that's the default name for the empty example template. We didn't change the name in the previous exercise. We will do it now, but we will not do it in the Finder, and I will explain why. So we'll double click. Here we are in our good old hello world exercise. So to rename, we select the project icon here in the file browser, and when it's selected, we click and hold, or click and wait, I think is the best term to define this, because we just click, we just tap, and we wait, and then we can rename it. I'm going to call it GraphicsMatrix, and then I press enter, and Xcode will suggest to change a few files, not just the project file, but the target, the application file will all be changed into GraphicsMatrix, and I'm going to rename it. And I say OK. Fine. Now they're all renamed. So if I press build or run, what will happen is that Xcode will create a build, will compile the code, will create a build. It's exactly the same as before in terms of the code. We didn't change the code, but the name has changed. Now it's GraphicsMatrix Debug. There's the debug name here. I'll explain why it is there. So if we close it and if you go to the Finder, to the bin folder, we had the old empty example debug. Actually, we can get rid of it. And there's the new one is the GraphicsMatrix debug. It's a Mac OS app. We can double click, it will run. You can send it to a friend that has a Mac, and it will run. However, it's a debug. It's a debug application, and it has this kind of debug ribbon there. Why? Well, you have two schemes by default. You have a release scheme and a debug scheme. And the target is your Mac. We don't have any other devices plugged in. If we had iPhones or something like that, it would show here. In this case, it means that the debug scheme you use when you're still testing, you're still building, you're still developing, and you want to be able to debug, to use debug tools such as inspecting variables during runtime and things like that we'll probably see later on in the course. With the release, it will not. If you pick the release and you build a release version, it creates a release app. You cannot debug it while you're developing, you're running it, but it will create kind of a polished final app ready for distribution. You can change these icons. It's a little bit time consuming, and there's a bit of work involved. I'm not gonna go through that now. If you're interested, I can show it in class probably. because there's many versions of the icon, many sizes and retina, non-retina, etc., 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 that you need to create, and we're not going to go through that now. What I want to go through is that to show you that these schemes, they're also cosmetic. They don't have importance in terms of what gets developed or not, but they don't get renamed by default like the other stuff. If you want to rename it, you need to go to Product, Scheme, Manage Schemes, and then change, again, click and wait, GraphicsMatrix, and manually change this. It's a bit, you don't really need to do it, but I'm just, for the sake of demonstration, I'm doing it. Later on in a future exercise, probably the next one, I'll show you how to use the project generator so you don't have to do all this renaming. Project generator does all this for you when you create the new project. I just want to show you different ways to create projects, because sometimes it's useful to duplicate pre-existing ones and rename, because we're using assets as we are here, the font. So for this exercise, let's go back to our code. What I want to do is I want to have our font rotating, our text rotating in the screen. And first I want to draw it in the middle of the screen. So I'm going to replace these 100 pixels by the middle of the screen. The middle of the screen is defined. We can get the size of the screen and then divide it by 2. And we can get the size of the screen using two openFrameworks methods. One is of get width, it gets the width of the screen, and of get height gets the height of the screen. And in the documentation, I'm not entirely sure which class. I think it's of app runner. So if I find of app runner, here we go. We have of get width. So anything that relates to the main app, to the run to the main context of the app running is the class of app runner. So you get of get width, and you get of get height as well. Here we go. And it's also useful for finding the middle of the screen, like they are exemplifying here, which is exactly what we're going to do. So as you see, usually I use the browser find function instead of the reference search option. It's just faster, so I just expand everything, and if I want to see height, it finds everything a bit quicker than having to go here, get height. It just takes longer time, right? And the result, it's harder to go through the results. In my view, I mean, it's a question of preference. Use what you prefer. So where was I at? I was going to go and replace this by of get height, sorry, get width, because we're in the x-axis, width divided by 2, and this 100, I'm going to say of get height, parentheses, divided by 2. Parentheses, because it's a method, right? So methods have parentheses. You probably saw this in processing. We know these numbers. We could hard code them, because if we go to main CPP, we have this is actually the main point of this main CPP is to set the size of the window. So we could divide this by so it's 512, right? Here, but we could decide to change it later here, and then we'd have to change it everywhere. So it's always better to use these kind of methods to retrieve this information, because windows can be scaled, etc. So it's good to have kind of relative positions there. By the way, in main CPP, you could replace of window by of full screen, and when you run the app, it would run full screen by default. Okay, so what happens when we now run? I want to go back to debug, because when I'm developing, I like to use the debug scheme. So I'm going to run. We're just going to see hello world centered on the screen. It's not a natural centering. It's just centers where it starts to be drawn. It would be a different exercise if we would aim to center the text. Then we'd have to get the string width and the string height. That's also possible, but that's not what I want to do in this exercise. I just want to rotate the text, and I want to rotate the text in the y-axis. So the y-axis is the vertical axis. There's a function, there's 3 rotations, because openFrameworks is 3D by default, so you get the rotate x, rotate y, rotate z. So if you imagine kind of a vertical line here, and then hello world rotating almost in the axis of this vertical axis of the edge, that's rotate y, because the y is the y-axis here. And if you wanted it to rotate along the middle of the edge here, that would be rotate x, right? And rotate z would just make it spin as like the hands of a watch, right? That would be rotate z. If you want to check that in the graphics module here, we have of graphics, and we have of rotate x, of rotate y, of rotate z, and you have radians and degrees. I prefer degrees. Usually, for some functions, radians is better, but for simple things, degrees I think is more intuitive. So to rotate what we need to do, actually we don't need this legacy bitmap string here. This is from the previous exercise. What we need to do to create a rotation is to use this function, right? So of rotate, I lost it. Where is it? Okay, here we go. Of rotate y deg, okay, and then between the parentheses you add the value, the angle of rotation. So using this example, actually this example is actually deprecated because we need deg there now. In the old openFrameworks, there was no deg and rad, everything was deg, and now there's this deg and rad. So of rotate y deg, let's use the example of the 45 degrees, right? Don't forget the semicolon in the end of each line. So if we run it, let's wait for the compilation to finish. So here we go. It kind of rotated it 45 degrees inwards, right? Now let's imagine you want to animate this, not have a fixed number here, but a kind of constantly evolving number. So usually we have one default constantly evolving number in openFrameworks, which is of frame num. So frame num, I need to expand all. So can't maybe frame num. Okay, here we go. Of get frame num gets the number of frames. So openFrameworks uses a frame metaphor. That means that 1 second, so the default frame rate in openFrameworks is 60 seconds. That means that, sorry, 60 frames per second. That means that openFrameworks starts with a frame num 0, and then goes 1, 2, 3, 4, 5, 6, 7, 8, and then by the end of 1 second you have 60 frames counted, right? So this, the frame metaphor comes from cinema and the idea that to create illusion of animation, you create succession of you add images in rapid succession, and your eyes perceive it as a continuous animation when it's not. It's kind of discrete, right? But openFrameworks uses this. Well, not just openFrameworks. A lot of software animation uses the metaphor of frames and frame rates, and you can get this number, this default number, default evolving number. So going back here, so we can replace 45 by of get frame num, right? And we have Aalto, this kind of autocomplete. So what happens when we run this? Something interesting and funny, I think, will happen. You see, the text is rotating, but it's rotating. The center of rotation is actually the 0, because that's the default center of rotation is 0. So if we wanted the center of rotation to be the middle of the screen, so that the H would kind of spin in itself, let's say in the edge of itself, we need something called a matrix transformation. So to change this, the default center of rotation, we need to change the coordinate system, actually. So we need to change it to the center of the screen. And how do we do it? We need a transformation matrix. So transformation matrix is in graphics. Again, I need to collapse and then go to graphics and then go to the module documentation of graphics. So to start a transformation matrix, you need a of pop matrix, and then to end it, you need a to start a transformation matrix, you need the of push matrix, and then to end it, you need the of pop matrix. So let's see what the explanation here is. Of push matrix saves the current coordinate system, allowing users to develop specific movements, and of pop matrix needs to be called after. This kind of push and pop is a common terminology in C++, with push means add and pop means remove. So you add a matrix and then you remove it in the end. And it acts like a parenthesis, push and pop, so beginning and end. And everything which is in the middle gets affected by the transformation matrix. What is outside doesn't. So it's useful when you have multiple graphical elements and you want to transform some but not the others. Or when you want to do rotation, which is what we want to do now, and change the center of rotation. So I will just then do a of push matrix here, and then a of pop matrix in the end. And to change the center of rotation, we need something called of translate. So it's not Google Translate, but it's translation, meaning moving. Of translate produces a translation by x, y, z vector of our coordinate system. The call of auto translate modifies graphics positions. use of push matrix and of pop matrix to save and restore the untranslated coordinate system. So let's translate our coordinate system. So of translate, and the float x, I want x to be the middle of the screen. So of get width. And I want a middle of the screen, so of get width divided by 2. And I want y to be also the middle of the screen, but in the y-axis, so it's of get height divided by 2. Now, because our coordinate system is now the 0 point, or the origin of our coordinate system is now the center of the screen. So if I draw, by adding values here, I'm adding to the center. So if I leave of get width 2 and of get height 2 here, if I add a half of the screen to a half of the screen, that's the bottom right corner. So that's, I'm adding a half of the screen to a half of the screen. So that means our text will almost disappear. It will be in the real, in the corner there. So that's not what we want. So I'm just gonna put here 0, 0, and 0. I'm gonna draw, I'm telling Xcode that I want hello world to be drawn in the center, because 0 is our center now. So the consequence of this is, you see that now hello, instead of hello spinning along the kind of left axis of the screen, hello is spinning around an axis which is the center of the screen, which is more elegant in my view. So that's about it. I just want to add a little twist here, which is I want the hello world to move. So I want this translation not to be a static translation, but kind of a dynamic translation. So how would we do this? So I want hello world to move left and right of the screen, but I don't want to move it in a kind of mechanical way. I want to move it in a kind of organic way. And for that, I use a lot in this kind of animation, which has kind of easing in and easing out, or acceleration, deceleration. I use a lot sine, and sine creates a sine wave, right? That goes from -1 to 1. So the translate, instead of being a static number, I want it to be a sine. Okay, I want to be a sine of something. But sine goes from -1 to 1, and I want my text to move from 0 to of get width, which is the right, from the 0 is the left edge of the window, and of get width is the right edge of the window. So I need to map -1 and 1 of the sine to 0 and of get width, right? So how do I do this mapping? Well, we have a function in openFrameworks which is called ofMap, which is similar to processing in other languages, which is really, really useful. When I use ofMap, usually I use a helper variable, just a local variable. We'll talk more about global and local variables later, but it's just a local variable where I store the mapping, and then I use the variable, but just a little helper variable, because to put ofMap function, you'll see it's really big. It will just make this into an ugly line of code. So I'm going to create a new float, a new variable. We'll discuss in another time types of variables in C++ and openFrameworks. But I'm going to call this posX or myX. I don't know. We could call it whatever we want. But I'm not done with it. But I just want to show you the ofMap function. So let's go to here we go, to our reference, expand all, find ofMap. Here we go. What is ofMap? So it's a math in the class of math function, and it has basically it lets you get an output value based on an input value, and you need basically you need 5 parameters. The input value, so it's the variable basically that you are using. In this case, it will be the sine value. Then the input minimum in the case of sine is -1. The input maximum in the case of sine is +1. The output minimum, so you're mapping sine to the screen, so the minimum of the screen is 0, and the maximum of the screen is the width. We're not clamping, so we don't need this. It's an optional one. So it becomes clearer, I think, if we exemplify. So the position x basically is a mapping, is an of map of the sine, and the sine you write it like this, and well, it's not a sin, it's a sine, but still you need to calculate the sine of something, right? We need a constantly evolving number here. Oh, we already saw that we have one, which is of get frame num, and the input minimum of sine that comes from math is -1. Maximum of sine comes from math is 1. The input minimum will be 0. It's the left of the screen. The input maximum is of get width, which is the right of the screen. And that's about it. Just the only tricky thing here is that this might be a tad too fast. And if it's so, we can just divide the get frame num by a value, by a fraction. We can make it into a fraction, because this might be too fast. So now we have this variable, and I just want to replace the translation. Instead of being a fixed in the x-axis, it's going to be this variable, right? Okay, so let's get to it. We might have a couple of problems here. Also, we might have a problem with this fraction. Yeah, so we have two problems here. There's a jumpiness, and there's a issue of speed. So let's try to address both. First, I'm going to address the issue of speed by dividing the frame num by 10, for example. I'll see how that goes. It should slow down the rotation, but there's still going to be a jumpiness. Now I'm going to explain why that jumpiness occurs. So it's slower, but it's jumping, right? It doesn't seem smooth. What's going on here? Well, what's going on is something that we need to pay a lot of attention in C++, which is what is a float and what is an integer. And if we go to of get frame num, so that's in of app runner, anything related to the running, to the kind of the context of the app is in of app runner. So of get frame num is an integer, unsigned. Well, we're gonna discuss types. It's an integer, and because it's an integer, so frames go like 1, 2, 3, 4, 5. They don't go as fractions. They go as or as floating points. They go as integers, and we're dividing an integer by an integer, and we're calculating the sign of an integer. So everything becomes an integer. So that's what we don't want integers. We want floats, so that we have kind of a more linear way. So a quick way to transform an integer to a float is just to instead of using a number here without a floating point, we just add a floating point, and that triggers. There's other ways to do this, but this should trigger the transformation of this number into a float. You see, it doesn't jump anymore. There's just this kind of psychedelic movement. It's not jumping anymore. It's just a bit too fast still. So if we would divide it by 100, it could be slower and a little bit more. It's almost like a choreography. It's maybe a little bit too slow. It went from one extreme to the other, right? But something in the middle is probably the best. There you go. I think this looks good. Maybe 20 divided by 20 or 30, something like that, would be even better. But you get the point. So this is the result I wanted to achieve with the transformation matrix. We have a rotation, and we have some movement, some translation in the x-axis. And this concludes the exercise for now.